We will finish up 1.2, displaying quantitative data with graphs. First, we have our warm-up here. There are a number of points scored by the teams in the California Division IAAA High School Basketball Playoffs. On the same day, the final scores of games in Division VAA were as such. Construct a back-to-back stem plot to compare the points scored by them. Here's our back-to-back stem plot. Again, we start with our stem, which is the ones position or tens position, and then we have to throw in a 10 there because we go up to 106, but since this doesn't have the same number of digits as all the rest, that's why we have that 10 there instead of a 1 and an 06. So just look at the values, least to greatest on from each stem. Remember that the IAAA here is going backwards, so 36, 37, 37, 44, 44, 45, 46. So this is 98 down here, not 89. Make sure you're seeing that. Now, if we want to discuss the differences and similarities of these two sets, the shape of the AAA scores is somewhat normal and somewhat uniform, whereas the scores for VAAA or AA are somewhat skewed right. I kind of drew the shapes as well. Skewed right, we have a lot more lower values than higher. There may be possible outliers for VAA at 106, maybe 91, but IAAA doesn't have any obvious outliers. The center of the IAAA is in the 60s, which we can also say about VAA. However, the IAAA is probably lower. So you can kind of see that you're estimating until we get to actually some stats. And lastly, the range of IAAA scores is 62, and the range of VAA is a little bit higher at 68. The VAA scores are more spread out than IAAA. And again, we'll find different measures of spread to find there, but for right now, range is fine. Now moving on to our newer stuff, we're going to talk about histograms. Histograms are probably the most prevalent graph that you're going to see in the AP exam. We can either graph frequency or relative frequency. Notice these two graphs are identical, both fuzzy as well. One is the frequency where it actually has a number of states, up to 20 here in that category, where we have the percent in this one. And again, the graph looks identical, except our numbers on our y-axis. So when we do this, we have an x-axis labeled with the lower class limits. So this starts at 5, the next one starts at, or this one starts at 0, sorry. The next one starts at 5, 10, and so on. So it's going up at 5. So when we are making one, we want to split up, we got to split up the data into classes. There are intervals that qualitative data is grouped into, quantitative data is grouped into. Classes need to be the same width. So however many classes you want, you have to figure out. Minimum 5, I would say between 5 and 10. Find the range of the data and divide it by the number of classes to find the class width that you're looking for. And we got to round up, just because if we don't, the last piece of data won't be in a class. So we find the frequency or relative frequency of individuals in each class, label and scale both axes of your histogram, give your histogram a title, the most descriptive one we can, and only the lower class limit, beginning of each class, is labeled. Sometimes the classes are called bins. What your calculator uses, it's the same thing. The first and last class have to have data in them, or else we don't have that class, just get rid of it. So for instance, we're looking at our AAA, our IAAA scores. So first, we probably want to put them in order, and then figure out, I guess we figure out the classes first. So the range is 68. Biggest value is 106, smallest is 38. Subtract them, you get 68. Divide by 8, because we decided we want 8 classes. So each class would be 8.5, but again, we got to round up, so the width is 9. And we don't have to start at 0. Probably shouldn't start at 0, because our data doesn't. Data starts at 38. So I'll start at 30, And 38's barely in there, but it's in there. So now we're adding 9 to each lower limit to find the new lower limits. And we have to go back 0.1 so we can get 38.9 here. Because it doesn't go all the way up to 39, it goes up to 38.9. And then we add 9s on here too to keep getting the upper limits of our classes. Then we just mark how many times we see a number in that range, or in between those values. And we're just graphing our box plot here. Again, we only graph the lower class limits, 30, 39, 48, 57, and so on. We have our y-axis with our frequency. It somewhat matches. We have it labeled as frequency. We have the points scored as our x-axis. And we have a title, points scored by IAAA teams in the playoffs. We also need a break here because we didn't start at 0, because there's no point. Our lowest value is 38. So we start at 30 in this case, that's what we decided. Then we have to put a break in to say from 0 to 30. Because from 0 to 30 is not 9, but from 30 to 39 is 9, 39 to 48 is 9, and so on all the way to the end of it. So we need that break. Now, what are the same and different compare and contrast histograms and bar graphs? Well, the biggest difference, we look down here at the histograms. Histogram is quantitative data, bar graph is categorical data. So they have the same type of data. They're both made up of rectangles. Both have 2 axes, both are labeled. They both have titles. The rectangles need to be the same width. It could be relative frequency and frequency. What's different? Histogram have the bars touching. If we zoom out a little bit here and we look down at the 2 graphs, you can, in the histogram, all of them are touching, except for here, because there's a class with no data in it. That's okay. Whereas the bar graph, you spread them out just however you want to, making sure each class is the same width though. We need the frequency table to set it up. So we need to know how many times something happens, whether it's percent or frequency, relative frequency, or actual frequency, it doesn't matter. More calculations for histogram, we got to find the range, we got to figure out what goes into what. Bar graphs, a little bit easier to get the data from. Again, histograms are quantitative, bar graphs are categorical, and it's classes versus categories. Classes have a range of values. Categories just, it is that category. When comparing 2 sets of data, we use relative frequency because the sets may not have the same number of counts or frequencies. If one has 80 and one has 2, we're not going to get a good comparison. Then our last problem here, many people, the distribution of IQ scores follow a bell curve or normal distribution. But is this really how scores are distributed? The IQ scores of 60 fifth grade students chosen at random from one school are shown below. So we need to graph those. If we graph them into a histogram, this is what it looks like. We got our frequency on the y-axis, our label of the scores on the y-axis or x-axis. We got a break because we didn't start at 0, we started at about 40. And the lower class limits are each multiples of 10, made it nice and easy. This is a pretty good looking graph. We have a title, a break, labels, numbers. We are good here.